Black holes are some of the strangest and most fascinating objects in space. They're extremely dense, with such strong gravitational attraction that not even light can escape their grasp. The Milky Way could contain over 100 million black holes, though detecting these gluttonous beasts is very difficult. At the heart of the Milky Way lies a supermassive black hole, Sagittarius A star. The colossal structure is about 4 million times the mass of the Sun and lies approximately 26,000 light-years away from Earth, according to a statement from NASA. The first image of a black hole was captured in 2019 by the Event Horizon Telescope (HT) collaboration. The striking photo of the black hole at the center of the M87 galaxy 55 million light-years from Earth thrilled scientists around the world. Black holes are expected to form via two distinct channels. According to the first pathway, they are stellar corpses, so they form when massive stars die. Stars whose birth masses are above roughly 8 to 10 times mass of our Sun. When they exhaust all their fuel, their hydrogen, they explode and die, leaving behind a very compact, dense object, a black hole. According to the first pathway, they are stellar corpses, so they form when massive stars die. Stars whose birth masses are above roughly 8 to 10 times mass of our Sun. When they exhaust all their fuel, their hydrogen, they explode and die, leaving behind a very compact, dense object, a black hole. The resulting black hole that is left behind is referred to as a stellar mass black hole, and its mass is of the order of a few times the mass of the Sun. Not all stars leave behind black holes. Stars with lower birth masses leave behind a neutron star or a white dwarf. Another way that black holes form is from the direct collapse of gas, a process that is expected to result in more massive black holes with a mass ranging from 1,000 times the mass of the Sun up to even 100,000 times the mass of the Sun. This channel circumvents the formation of the traditional star and is believed to operate in the early universe and produce more massive black hole seeds. Black holes were predicted as an exact mathematical solution to Einstein's equations. Einstein's equations describe the shape of space around matter. The theory of general relativity connects the geometry or shape of shape to the detailed distribution of matter. The black hole solution was by Carl Schwarzschild in 1915, and these regions, black holes, were found to distort space extremely and generate a puncture in the fabric of spacetime. It was unclear at the time if these corresponded to real objects in the universe. Over time, as other end products of stellar death were detected, namely, neutron stars seen as pulsars, it became clear that black holes were real and ought to exist. The first detected black hole was Cygnus X1.
Du black holes die?
Black holes do not die per se, but they are theoretically predicted to eventually slowly evaporate over extremely long time scales. Black holes grow by the accretion of matter nearby that is pulled in by their immense gravity. Hawking predicted that black holes could also radiate away energy and shrink very slowly. Quantum theory suggests that there exist virtual particles popping in and out of existence all the time. When this happens, a particle and its companion antiparticle appear. However, they can also recombine and disappear again. When this process occurs near the event horizon of a black hole, strange things can happen. Instead of the particle-antiparticle pair existing for a moment and then annihilating each other, one of them can get by gravity and fall into the black hole, while the other particle can fly off into space. Over very long timescales, we are speaking about timescales that are much longer than the age of our universe. The theory states that this trickle of escaping particles will cause the black hole to slowly evaporate. No, black holes are not wormholes. Wormholes can be thought of as tunnels that connect two separate points in space and time. It is believed that the interior of black holes could contain a wormhole, the puncture of spacetime, that could offer a portal to another point in spacetime, potentially even in a different universe. Albert Einstein first predicted the existence of black holes in 1916 with his general theory of relativity. The term black hole was coined many years later in 1967 by American astronomer John Wheeler. The first black hole ever discovered was Cygnus X1, located within the Milky Way in the constellation of Cygnus, the Swan. Astronomers saw the first signs of the black hole in 1964 when a sounding rocket detected celestial sources of X-rays, according to NASA. In 1971, astronomers determined that the X-rays were coming from a bright blue star orbiting a strange dark object. It was suggested that the detected X-rays were a result of stellar material being stripped away from the bright star and gobbled up by the dark object, an all-consuming black hole. According to the Space Telescope Science Institute, STSCI, approximately 1 out of every 1,000 stars is massive enough to become a black hole. Since the Milky Way contains over 100 billion stats, our home galaxy must harbor some 100 million black holes. Though detecting black holes is a difficult task, and estimates from NASA suggest there could be as many as 10 million to a billion stellar black holes in the Milky Way. The closest black hole to Earth is dubbed the Unicorn and is situated approximately 1,500 light-years away. The nickname has a double meaning. Not only does the black hole candidate reside in the constellation Monoceros, the Unicorn, its incredibly low mass, about 3 times that of the Sun, makes it nearly one of a kind. In 2019, the Event Horizon Telescope (EHT) collaboration released the first image ever recorded of a black hole. The EHT saw the black hole in the center of galaxy M87. While the telescope was examining the event horizon, or the area past which nothing can escape from a black hole. Black holes have 3 layers: the outer and inner event horizon, and the singularity. The event horizon of a black hole is the boundary around the mouth of the black hole, past which light cannot escape. Once a particle crosses the event horizon, it cannot leave. Gravity is constant across the event horizon. The inner region of a black hole, where the object's mass lies, is known as its singularity, the single point in spacetime where the mass of the black hole is concentrated. Bright jets of material traveling at near-relativistic speeds are created. Although the black hole remains unseen, these powerful jets can be viewed from great distances. The EHT's image of a black hole in M87, released in 2019, was an extraordinary effort, requiring 2 years of research even after the images were taken. The next target is likely Sagittarius A*, which is the black hole in the center of our own Milky Way galaxy. Sagittarius A* is intriguing because it is quieter than expected, which may be due to magnetic fields smothering its activity, a 2019 study reported. Another study that year showed that a cool gas halo surrounds Sagittarius A*, which gives unprecedented insight into what the environment around a black hole looks like. For smaller stars, those up to about 3 times the Sun's mass, the new core will become a neutron star or a white dwarf. But when a larger star collapses, it continues to compress and creates a stellar black hole. Black holes formed by the collapse of individual stars are relatively small but incredibly dense. One of these objects packs more than 3 times the mass of the Sun into the diameter of a city. This leads to a crazy amount of gravitational force pulling on objects around the object. Stellar black holes then consume the dust and gas from their surrounding galaxies, which keeps them growing in size. Supermassive black holes, the birth of giant small black holes, populate the universe, but their cousins, supermassive black holes, dominate. These enormous black holes are millions or even billions of times as massive as the Sun, but are about the same size in diameter. Such black holes are thought to lie at the center of pretty much every galaxy, including the Milky Way. Scientists aren't certain how such large black holes spawn. Once these giants have formed, they gather mass from the dust and gas around them, material that is plentiful in the center of galaxies, allowing them to grow to even more enormous sizes. Supermassive black holes may be the result of hundreds or thousands of tiny black holes that merge. Large gas clouds could also be responsible, collapsing together and rapidly accreting mass. A third option is the collapse of a stellar cluster, a group of stars all falling together. Fourth, supermassive black holes could arise from large clusters of dark matter. This is a substance that we can observe through its gravitational effect on other objects. However, we don't know what dark matter is composed of because it does not emit light and cannot be directly observed. Such bodies could form when stars in a cluster collide in a chain reaction. Several of these IMBHs forming in the same region could then eventually fall together in the center of a galaxy and create a supermassive black hole. In 2014, astronomers found what appeared to be an intermediate-mass black hole in the arm of a spiral galaxy. And in 2021, astronomers took advantage of an ancient gamma-ray burst to detect one. Astronomers have been looking very hard for these medium-sized black holes. Study co-author Tim Roberts of the University of Durham in the United Kingdom said in a statement,